So thank you everyone for joining today's Hyperledger meetup about enhancing blockchain security and automation with OpenZeppelin Defender on Besu. Today we have Bram and Amin speaking to us, so take it away.
Perfect.
Hey everyone. Yeah, maybe first like a small introduction. I'm Bram, part of the solutions team at OpenZeppelin, normally based in Amsterdam, the Netherlands, but currently in Austin, Texas. So, I mean, go
Yep.
ahead.
Thank you. Hi, everyone. So my name is Amin. I'm based in Paris, and I lead our BD efforts for financial institutions. So my role on a daily basis is helping those institutions kind of dive into smart contract development and making sure it's fully secured before and after deployment. All right. So today, as agenda is pretty straightforward. We're gonna give you a demo of our tool, Defender, to see how you can leverage with Besu. And I just want to give you, before Brian kind of take over on the demo side and the technical side, a quick view of what is OpenZeppelin for the one who don't know, and just give more precision for those who don't know everything that we do in the company. So one of our main missions since 9 years now is protecting the open economy around blockchain. The company was founded in Buenos Aires in 2015. Today, we are around 120 people in the company across the globe. It's not only based in Argentina. And I think historically, the company, and that's the cool part with OpenZeppelin, started with an open source smart contract library. So we were very happy to also work on the Hyperledger Besu, who has kind of a similar approach to open source development as well. And it started in 2015. Today, these contracts, the EVM ones, are actually has been transferred value of more than $6.7 trillion. So it became kind of a huge standard, an ERC20 standard, ERC 1721 standard. And on top of this kind of open source library, we've conducted a lot of security audits on kind of the names you've seen here on the right. So mostly Web3 platforms initially, like Uniswap, Aave, Polygon, then also some custodians like Coinbase or BitGo. And recently also, we've seen some uptake on the enterprise side and also bank side in general. And we've been working with, for example, ANZ, the first bank to create a platform to tokenize assets. Mercado Libre as well, which is an e-commerce in South America, and NAB as well. And overall, we protected more than over $40 billion in terms of TVL, and we will keep pushing to protect the open economy. Bram, can you go to the next one? Thank you. Just to give you full view here, so as I mentioned, we have the open source smart contract library. We also do have the audits that OpenZeppelin is pretty famous for. But then the last piece is the Defender side that today we're happy to present you, especially regarding the integration with Besu. Just some side notes before I hand it over to Bram. We also spin off a company called Forda, which is a security and operational monitoring network, fully decentralized, that is today a good partner of OpenZeppelin as well in our mission to secure the open economy. Bram?
Yes, so thanks, Amin. And yeah, as Amin already mentioned, I'm going to like showcase OpenZeppelin's Defender today, and especially in combination with Hyperledger Besu. So when you like spin up your own network, like how would you use it within OpenZeppelin Defender? And Defender is a developer security and operations platform, which includes or which helps you with like securely coding your smart contracts and deploying them, and also setting up secure monitoring and automation around your smart contracts. So let's dive into the demo. Over here, you can see the Defender dashboard. And it's kind of separated into two phases. So we have the pre-deployment phase, which includes modules like code inspector, audits, and deployment, which help you kind of like streamline the whole development process for your smart contracts and securely deploying it. And the second phase is more of like an operational and automation phase. So making sure that you have like secure operations around your smart contracts and automation around certain processes around the smart contracts. So let's first dive into the first phase, the code section. So we created a module called Code Inspector, which is a statistical analysis tool that you can use to search for or look for known vulnerabilities and code quality improvements within your smart contracts. So when you're developing smart contracts, you can install Code Inspector into your GitHub repository or your GitHub, then select the repository you want to scan for. And on every pull request that you create or when you manually trigger it, it will then scan for all the smart contract assets within your repository. It will then give you back a summary like this. It will kind of summarize the issues that were found within your smart contract. So for example, over here, we have like 5 nodes and 2 low severity issues, but like the same as with audits, usually you can also have like medium, low, high critical severity issues that this static analysis tool can then find. Over here, you then have some context around every issue. So where can you find the specific issue within your smart contract and like a possibility on like how or recommendation on how to resolve that issue. And yeah, this is like, it's really easy to use, just like install it within your GitHub, select a repository, and that's it. And that kind of, then we transition kind of into the next phase, which is audits. And audits, if you do an audit with OpenZeppelin, you will kind of have the same dashboard as you saw with Code Inspector, an overview of all the different issues, like vulnerabilities and code quality improvements that were found by our auditors. But what audit, like the audit module also does is it allows you to directly communicate with the security auditors at OpenZeppelin to talk about different issues that were found in your smart contract and to make sure that you can like resolve all the issues before going to the next phase, which is deployments. And what the deployment module for you does is it kind of simplifies and the way of like deploying smart contracts on chain. So we kind of made a module to like create a simple interface to deploying smart contracts on chain and also make sure that the deployments are secure. And over here, we can kind of see the first time that we are working with network. So in the previous modules, you are not working with a specific network, but over here you can see that you can create different environments. So I created a test environment and a production environment. And in this case, the production environment is the Hyperledger Besu network that I spun up myself. So we have a list of standard integrations within OpenZeppelin, but if you, of course, like launch a network yourself, it's not part of the standard integration. So what you can do is create a private network to leverage all these different modules within OpenZeppelin. And let me quickly show you how that works. You can create a network by clicking on the Add Network button, and subsequently you will see this screen. So what you can do is like insert a name, RPC URL, and the currency symbol, and this will allow you to then spin up your own private network. Then if you created this private network, you are able to use it within all the different modules. So let's have a look at the deployment module. Over here, you will see an overview of all the different deployments and upgrades that I've done. So over here, you see 2 deployments that I've done. If you click one of those deployments, you have like a general overview of the information within the smart contract, the state, and the ABI of the contract. Then above Over here, you can see a couple of titles like deploy approval process and upgrade approval process. And what this means is if you set the deployment approval process to, for example, an EOA in this case, which means this is my wallet, I'm able to execute deployments through the vendor deployment module. But it's also possible to execute upgrades. So if your smart contract is upgradable, you can also execute upgrades through Defender. But what we require you to do is to have a multi-sig wallet as the upgrader role within your smart contract. Because if you have a single EOA that can, for example, execute an upgrade, that could be a vulnerability in your kind of upgrade pipeline. So what you have to do is let multiple people sign an upgrade before you are able to actually execute this upgrade. Then what the deployment module also does, if you want to deploy a smart contract to multiple environments and multiple networks, it also does the nonce management for you. So it makes sure that your smart contract has the same wallet address on multiple networks, or sorry, same address on multiple networks. So then we get to the second phase, the post-deployment phase, which is more about like operations and automations. And over here, we have a couple of interesting modules that I want to talk through. The first one is monitoring, where you can like easily set up monitoring instances, actions, which is also in part a module that allows you to create a bit more complex monitoring instances, for example, cross-chain, and do your automations around your smart contracts. And then we have relayers, which are private key securely stored by OpenZeppelin. But yeah, we will dive a little bit deeper into that shortly. So over here, we have the monitoring module. And I created a couple of examples to showcase what you can do with this module. It gives you like all the freedom in the world to kind of create your own monitoring instances, but these are a couple of examples that I wanted to showcase. You can, again, really easy create a monitoring instance by just like adding a new monitor here. And what you will then see is this UI, where you can give the monitoring instance a name, then like a risk category, which is just a label that you can assign to the monitoring instance, and the smart contract that you actually want to monitor. And over here, we have a couple of filters that you can add to a monitoring instance to filter for certain events. So first, we have the transaction filters. So for example, if you want to filter for a certain address interacting with your smart contract, you can add conditional logic like this. And for example, filter for a certain address interacting with your smart contract. But in this case, we want to monitor for access control changes, and it's what we want to do is filter for a function that is being called. So in this case, we filter for the grant role function. So every time that this function is being called within the smart contract, we alert the dev team to take a look at it, because in the case that it's an authorized function call, it's still good to know, okay, this function was being called by someone within our team, but it could also be the case that it is like an unauthorized function call by someone that had still access to the smart contract and is trying to gain access to certain critical functions. So this way your team gets alerted and someone within your team can have a look at it to see if it's an authorized access control change within your smart contract. And over here, you see that I created different channels within the email. So you're able to set up all these different channels with different lists of email addresses. But it's also possible to set up different communication channels like Slack, Telegram, Discord. But it's also possible to export all of this monitoring data to maybe monitoring SaaS tools that you're currently using or incident response tools. A couple integrations that we already provide is Datadogs, Opgenie, and PagerDuty, but we can have a look at that a little bit later. And then I have a couple of other examples that I wanted to showcase. So for example, this is a like stablecoin large transfer monitoring instance we kind of do the same as in the previous monitoring instance, but in this case, we don't filter for the grant role function, but for the transfer and transfer from function. And what you can do is create conditional logic for your parameters within the function call. So for example, in this case, we only want to filter if there's a transfer that is higher than 1 million ETH in this case. If that happens, we then subsequently want to notify the compliance team to have a look at this large transfer. Then the last example that I created here for monitoring instances has a little bit more to it. So this is a APH, so the stablecoin unauthorized mint. And again, it's pretty similar. Over here, we also added a transaction filter. So we want to filter for all the addresses except this address, because this address would normally execute the mints within our stablecoin smart contract. And over here, we filter for the mint function, but we don't only want to, for example, alert the whole organization, but this is like a really critical monitoring alert. So we also want to pass the token contract to limit the damage that can be done to the token contract itself, but also to the whole ecosystem. So what you can do is execute a workflow, and this workflow subsequently executes a pass transaction to our like stablecoin contract. And this kind of transitions then into the next module that I want to talk about, and that is actions, which closely aligns with like automation around your smart contracts. So let's have a look at the workflows that we executed in this monitoring instance. So over here, you can create these workflows. These workflows consists of transaction templates or transactions that are being executed. And in this case, I only included the pass function that is triggered to our token contract. But what you can also do is, for example, pass other contracts that you have control over, for example, a bridge that you also control that is maybe closely related to this token contract, to make sure that you limit all the damage to like a lot of different contracts that are closely related to like the token contract. You can then like execute these transactions in a certain sequence or execute them in parallel. Over here, you can create these transaction templates. It's just like selecting the smart contract again, the function that you want to execute, and then you can include it in your workflow. So let's then go back to like the whole overview of actions. So it's not only possible to create these automated workflows within actions, but what also would be possible is to, for example, create a kind of cron job that executes on chain, for example, a weekly token summary of the token that you deployed on chain. So over here, you can like create a cron job, have a schedule of 7 days. So it's a weekly update to me. And over here in the code section, you can add JavaScript code to kind of summarize all the stats that you want to include. So for example, the amount of tokens being transferred that week, the amount of wallets interacting with your token, etc. And subsequently, you can again then send this to one of the notification channels that you created the same way kind of as I showed you within the monitoring instances. Okay, so this is an example of what you could do with actions, but there are also other examples, because you can also really easily create a webhook. So for example, if you want to like mint new tokens, you can create a webhook, which will then create a webhook URI for you. And when you call this webhook URI, it will then execute this JavaScript code. You can send a payload to it, for example, with the address you want to mint tokens to and the amount of tokens that you want to mint. And over here, I created a couple of different examples. We don't have to go into all of that. But for example, what you could also do about kind of the monitoring part, create a cross-chain monitoring action, which, for example, filters for certain events on 2 different chains, and then like cross-reference certain events for example, a bridge contract to see if all the like events check out and if the bridge is healthy. So this way you could also like set up, for example, a bridge health monitoring cross chain. And I created some other examples, like add an address to like a stablecoin's block list, etc. Then we have the next module, which is relayers. So relayers are private keys securely stored by OpenZeppelin, where we also do all the complex transaction management, like transaction submissions, resubmissions, repricing, gas optimization, and nonce management. So relayers are also like a part that is necessary for automations within this platform. For example, if you have that monitor that I showcased you with the unauthorized mint happening, and you want to pass the token contract, you of course need a private key to sign that pass transaction. So in this case, what you can do is like deploy a relayer onto your network. So in this case, my Hyperledger Besu network. And then you can kind of include this relayer into your automation process here in Defender to execute that pass transaction automatically. But you can also use these relayers outside of Defender. So this is also something that we see happening a lot. A lot of companies don't want to get into like developing all of this complex transaction management themselves, because it takes a lot of time and a lot of stuff that can go wrong. So what you can do is create a set of API keys over here, and then use these relayers from your own backend services. So you can kind of then communicate on chain by like using an API. So we provide a Defender SDK, which you can then use to like interact on chain, and you don't have to do all the transaction management yourself. Like we see examples of this being used in use cases, for example, like gasless transactions or the moving of funds between liquidity pools, rebalancing, automated airdrops, etc. So there are a lot of use cases for these relayers. Then a smaller module that is just maybe helpful to know of is the address book. So in the address book, you can keep track of all the addresses deployed on different networks. So over here you can see that I included my own EOA and the APH stablecoin contract that I deployed on Hyperledger Besu. And this also allows you to more easily use these addresses within Defender, but it's also just useful to keep track of the important addresses to you. And then the last module that I want to dive into is access control. So for people that have worked with access control, know that it's kind of difficult to get a transparent overview of which roles are present in the contract, or especially which addresses are assigned to a certain role. So normally you have to kind of manually check for every address which role that specific address has. But with the access control module, we kind of try to create a transparent overview of all the different roles within the smart contract, and also which addresses are assigned to these roles. So over here, you can see these different roles. You can then also easily remove a certain address from a specific role and add one, and then connect your wallet and execute these changes. And this will subsequently remove an address and add an address to your access control within your smart contract. And this is, of course, important for operational security to make sure that, for example, if someone leaves the company, and he still has a certain role within your smart contracts, that it's like visual immediately, okay, we need to remove this address from a role within the smart contract to make sure that we keep that operational security, and maybe do like weekly or bi-weekly checks on the access control within your smart contracts. So we can still quickly have a look at this. So this is are the notifications that I already talked about. So all the standard integrations that we already have with like Slack, Telegram, Discord, Datadog, Opsgenie, and PagerDuty. But if you want to do some custom work and you want to do some custom messaging or use another like monitoring SaaS tool that you're using, you can also create a webhook. That takes a little bit more custom work, but you can then also integrate Defender with every kind of monitoring tool that you are currently using. And then the last topic that I wanted to touch upon is Defender as code. So over here, you kind of have a UI in which you can create all these different instances, but it is also possible to create a configuration file within your repository where you have the proper access control and version control, and then define all the instances that you want to spin up within your Defender instance. And then you only have to execute one command and it like spins all these instances up within Defender. You can also set parameters like should this be the single source of truth? And there are some other configuration that is included within Defender as code. So yeah, to reiterate one point, if you want to use your own Hyperledger Besu instance within Defender and all the modules that I just showcased you just have to add a private network over here, and with like including your name, or sorry, the name of your network, the RPC URL, and the currency symbol, you're already able to use most of the OpenZeppelin Defender modules. So it's quite easy to set this up within Defender. And yeah, that's kind of a high-level summary of what is possible with OpenZeppelin Defender. And if you have any questions, feel free to ask. I guess there are no questions. Okay, thanks everyone. If someone wants to have maybe like a little bit more context or dive into the specific use case that you might be working on right now, you can always contact us. And we are happy to jump on the call to maybe do another walkthrough through Defender, maybe go a little bit deeper into the specific use case that you're interested in. So yeah, feel free to reach out, and yeah, thanks everyone for your attention.
Thank you, everyone.
Great. Thanks, everyone. Okay, bye all. I'll send a note out to everyone with the recording and any other links. Talk to you later.